Hello and welcome to a new video on the Crypto2 YouTube channel. This is the fourth video of our Crypto Challenge contest series. I structured this video into different parts. In the first part I want to give you an introduction of the contest. In the second part I give you the participation and winning rules. In the third part I will show you the solutions of last week's ciphers. In the fourth part I will give you the current best list of solvers. And in the fifth part I want to give you the new ciphertext of this week's video. This is the first Crypto Challenges contest of this YouTube channel. And you can win one of two copies of Gaines' book Cryptanalysis, a study of ciphers and their solutions, sponsored by me. Here on the right side you can see a picture of the two copies I have. As you can see, the copies are used, so these are not brand new books, but they are still nice and readable. All you have to do to win one of the books is to break the given ciphertexts, send me the solutions via email, and of course collect points. And please send your solutions via email to crypto2@gmx.net, and as a subject please use solutions to challenge video 4. Here are the participation and winning rules. This contest is in no way connected to or sponsored by YouTube, Google or Facebook. Everyone who is no Crypto2 member is allowed to participate. And you don't need to be a subscriber of our channel or our Facebook page, but of course I would be really happy if you subscribe. And the participation of course is for free. To win points, you have to send the complete plaintext of the ciphertext. You have to send a pseudonym which is used for the best list of solvers, as you will see on one of the next slides. At the end of the contest we will delete all personal data, for instance names and email addresses. The winners clearly have to send their postal addresses so that I am able to send the books. And the pseudonym will remain in the best list shown in my videos. And each solution of a ciphertext gives points. We have different difficulty levels. An easy ciphertext gives you 1 point, easy medium ciphertext gives you 2 points, medium ciphertext gives you 3 points, and hard ciphertexts give you 5 points. The solver on the first place of the best list will win a copy of the Gaines book. And if there are multiple solvers on the first place, that means that they have the same number of points, the winner will be chosen randomly from these. The second winner of a book will be selected randomly. But the more points you have, the higher is the chance to win the second book. So everyone has a chance to win a book. The winners will be announced in the last of the challenge videos next week. So this is the last video where you can get challenges or ciphertexts and solve these. The contest started with the video of the 14th of August 2020 and will last 4 weeks. Solutions of the last ciphertext are always shown in the next video about 1 week later. That means the solution may be sent only before the release of the next video. And as always, the basic idea of this contest is having fun with solving crypto challenges. Now let's have a look at solutions of last week's ciphertexts. And after showing you the solutions, I will also show you how you can solve most of these using Crypto2. This time there's only one challenge that you cannot easily solve with Crypto2, and that is the ciphertext 6. So the plaintexts are: first, contra vim mortis non est medicamen int hortis. The main thing here was that it was written in Latin and not in English. The second solution was, yes, this is a transposition cipher, but the ciphertext has been written reversed. The third ciphertext, to be honest, was also a little mean. It was double encrypted. And the solution is, yes, this is Navajo code. The solution of the fourth ciphertext was, this is encrypted using a simple monoalphabetic substitution, but we use ciphertext symbols which consist of numbers with different lengths. Solution 5 is, yes, here we have a lot of nulls. A null should make cryptanalysis more difficult, but after removing the null it is still a simple monoalphabetic substitution cipher. The solution of the sixth ciphertext was, the Hill cipher can be easily broken when you have enough plaintext and when you find matching pairs of plain and ciphertext. And the last solution was, the M138 script cipher machine used by the US Army, Navy, Coast Guard and State Department through World War II featured hundreds of flat cardboard strips. Each strip contained a scrambled alphabet, repeated twice, that could be slid back and forth in a frame, with 30 being selected for each cipher session. The strip cipher could interoperate with the M94 if suitable strips were provided. Now let's have a look at the solutions in Crypto2. I'm here now in Crypto2 and the solution of the first ciphertext was encrypted using a monoalphabetic substitution cipher. So we search for monoalphabetic. Then we have monoalphabetic substitution analyzer with arbitrary ciphertext alphabet, for instance. We remove this, we don't need this. We enter our text here, we remove this. We don't need this, this, and this. So actually it would be smarter to use a different template, but this also works here. Now let's have a look at the settings. We have hill climbing, and then we have Latin. Use spaces. Let's give it a try. And as you can see, it's not 100% correct. You have, for instance, here an L where we have a V, but nevertheless it can be solved easily using the monoalphabetic substitution analyzer. The next ciphertext was a transposition cipher, and to solve this we search for transposition cipher brute force analysis. Then we enter our ciphertext, and when we start this we have a problem since we do not see any meaningful solution. That is based on the fact that the ciphertext is written reversed. So we remove the connection here. We search for string operations component, connect these here. Then we set the string operations component to reverse. Let's have a look at the settings here. Brute force. Let's try it. And we have to change also the cost function, I assume. We have here log2 n-grams. And then it works. Yes, this is a transposition cipher, but the ciphertext has been written reversed. Now let's have a look at the next ciphertext. And the next ciphertext was a little mean. It was Navajo code, but the Navajo code was afterwards encrypted using a Caesar cipher. So we have to first solve the Caesar. I go to Caesar brute force analysis. I enter here my ciphertext. And to see that this is Navajo was more or less easy, you can say, with the dashes here and these kind of words. When you have seen Navajo before, you should recognize this. Of course, if you have no clue what Navajo is, then it's difficult. I also made a video about Navajo code, which is really nice. You can also have a look at this if you're interested in how Navajo actually works. But to solve this ciphertext, we just paste it into the ciphertext in this template here, in the Caesar brute force template. Press play. And then you have to search for the Navajo code. And here it is. I remember that this is Navajo, since Navajo has this tsa, as, tsi, a, na, etc. For me, this looks like Navajo. When you have a look at my video, you will recognize this probably also. So I copy this ciphertext here. And then in Crypto2 we have a Navajo template, Navajo code. You can just paste this here where we have plain text, but of course you have to change this component here to decrypt. Then press play. And then it takes this Navajo code here, substitutes it using the Navajo codebook here, and in the end we have, yes, this is Navajo code. The next ciphertext is also a little tricky. It's a monoalphabetic substitution cipher, but I used symbols of different length. You cannot solve these right now with Crypto2 since it is really a difficult challenge to find out which digits belong to which ciphertext symbol. So I show you now the solution using the key that I created. I use for that the homophonic substitution cipher and nomenclature decryption. I paste in the ciphertext. I paste in the correct key. And let's have a look at the key. And this is really complicated thing. You see here we have letters from A to I that consists of only 2 digits. And I made it a little easier for you to analyze this. The idea in this challenge is that the first digit tells you how many following digits we have. So for instance, for the space symbol, we have a 2 here, and then 2 following digits. And actually for the space symbol, I use 2 different homophones. So this is not only a monoalphabetic substitution cipher, you can say it's also a homophonic substitution cipher. And as I said, I used the digit 2 for 2 digits that follow that belong to the same symbol, and digit 1 for 1 symbol. So you have 10 2-digit ciphertext symbols, 10 to 19 here. And then the remainder here are 3-digit ciphertext symbols indicated by the 2 following 2 digits. And you have to find out these, for instance, by frequency analysis, by try and error. And as you can see here, when I press play, you can easily decrypt this. But coming to this here is fiddly. But nevertheless, many of you solved this challenge here. Now let's have a look at the next ciphertext. And the next ciphertext is also a monoalphabetic substitution cipher. So I open again monoalphabetic substitution analyzer, the template. A little more space here. And there was a trick with this cipher, you will see. So I paste in our ciphertext here. Let's have a look here. Hill climbing, use space, it's all right. Let's press play. And then we see we can partially read something, but we can restart it, and we never get a good solution. And this is due to the fact that when you make a frequency analysis of this here, you see that we have a lot of letter F. And the ciphertext that appears to be monoalphabetic begins with 2 times F. So the F doesn't make sense. There's no English word that starts with 2 letters. So let's search for a string operations component. Connect this here. Connect this here. And let's say replace the letter F with nothing. Meaning we remove the letter F since it seems not to belong to this text. And then let's try it again. And then we can see it immediately solved this, and we have now an English text that makes sense. And here's also the solution what the F was. The solution here is, yes, here we have a lot of nulls, so the F was a null. A null should make cryptanalysis more difficult, but after removing the nulls, it is still a simple monoalphabetic substitution cipher. As I already said, the next cipher is Hill cipher, and we don't have a solver for Hill ciphers in Crypto2. But to solve this cipher, you have to compute the key, and that is possible using mathematics. So you can create a matrix and then solve the matrix, and then using this matrix you can decrypt the remaining part of the ciphertext. And then we have our last ciphertext, and there was a hint that this is an US cipher. So there are actually not many US cipher machines or devices that you can use. And so we try the M138 cipher machine, strip cipher system, and we have a ciphertext only attack, and we just test it by pasting our ciphertext, having a look at this, hill climbing, offset 125 English. So let's test it. And then in the end you see it indeed was the M138, and here we have our plaintext, the M138, and so on. Now let's have a look at the current best list of solvers. So on the first place we have only one person remaining, that is Victor with 49 points. Then we have on the second place Silva with 46 points, Naga on the third place with 43 points, BL Dredge on the fourth place with 33 points, Hamatan on the fifth place with 27 points, Toasty on the sixth place with 26 points, Leah on the 7th place with 20 points. Then on the 8th place we have 10 Miles from Nowhere with 5 points. And on the 10th place we have Nils N and Viola with 3 points. Now let's have a look at the new ciphertexts. And first some remarks, as always. The type of used cipher is not given, only with hard ciphers. But of course the difficulty level is given. You have to copy the ciphertext from the video, but the texts are so short that it's not too difficult tedious, and in the real world you also have to make a transcription on your own. But clearly, as with the last videos, long ciphertexts are written below the video in the description. The difficulty level of the ciphertext varies, and in this video we have easy to hard difficulty. If we will have longer ciphertexts, I will provide the transcriptions. I already said this. In the future, videos may also have some modern cryptology related challenges, but not in this challenge series anymore, since these are the last ciphertexts I will give you in this challenge series. And this fourth video contains 7 ciphertexts. We have 2 easy, 1 medium and 3 hard. So you can gain a total of 20 points this week. And now I will show you every ciphertext about 30 seconds. You can make a transcription on your own and then try to solve these. And this is also the end of the video. Thank you very much for watching. Also thank you very much for participating in the contest. As already said, in the next video I will announce the winners. If you're not yet a subscriber of our channel, I would be really happy if you subscribe to our channel, and see you in the next video.